This is the second video of section 7.4, adding and subtracting rational expressions. This video shouldn't take too terribly long, just got one vocabulary term and 4 examples. So the vocabulary term is complex fraction. A complex fraction is simply a fraction that contains a fraction in the numerator and or denominator. So how do we go about simplifying complex fractions? Because that's going to be our task. Well, we're going to do step number 1, says simplify the numerator and denominator by writing them as single fractions. So like you can see down here in example number 1, in the denominator I have 2 separate fractions. What we want to do is make it look like something like the numerator where we just have a single fraction there. And then once we do that, we're going to multiply the simplified numerator by the reciprocal of the simplified denominator. Because remember, fractions ultimately mean dividing, and when we're dividing fractions, we flip the second one over and we multiply. So it's really no different than the dividing part of the first video once we get each side of the fraction simplified. So let's get right into it. Simplify. Number 1, 5 over x plus 4 over 1 over x plus 4 plus 2 over x. So we need to simplify the numerator and the denominator by writing them as single fractions. Well, the numerator, I would say this is already simplified. Okay, this one's simplified. The numerator, whoops, let me spell that correctly, simplified. Okay, I would say there's nothing we can do with the numerator because it already is written as a single fraction. Now, the denominator is a different story. Okay, so I'm going to rewrite the denominator down here in blue. So we got 1 over x plus 4 plus 2 over x. Now, think about what we did in the first video here. We need to find a common denominator. Okay, there are no common factors here. X plus 4 is a binomial. It's a degree 1. It cannot be factored down any farther. X is a monomial. That can't be factored down any farther either. So really, the least common multiple, or the least common denominator, is going to be x times x plus 4. Okay, and if you remember from the first video, to figure out what the numerator is going to be, we need to take the numerator that we choose times the opposite of the opposite denominator, or what wasn't circled. But we don't have anything circled here because there's no common factors here. Okay, so what we're going to do, we're going to turn this into 1 times x plus 2 times x plus 4, because those are the opposite denominators or opposite factors, over x times x plus 4. Okay, so 1 times x leaves me with x. 2 times x plus 4 is 2x plus 8. And all of that gets over, put a parenthesis there, x times x plus 4. And there's one little simplification we can do. We can simplify x and 2x to make 3x plus 8. So we'll have 3x plus 8 over x times x plus 4. That's the denominator. Okay, this is the simplified denominator right here. This is not our answer though, because what we're really left with, and I'm going to write this, we'll go back to purple here. The numerator did not change. It's still 5 over x plus 4, and all of that is going to be divided by our new denominator, this one right here, 3x plus 8 over x times x plus 4. So 3, whoops, I'll go back to the pen, 3x plus 8 all over x times x plus 4, okay? So remember, we've written them for step 1, simplify the numerator and denominator by rewriting them as single fractions. We've done that. Now we need to multiply the simplified numerator by the reciprocal of the simplified denominator. So what we're going to do, go back to the pen, equals, we're going to rewrite this. So we got 5 over x plus 4 times the reciprocal of the denominator. So x times x plus 4 goes on top. X times x plus 4 goes on the top. And then on the bottom is going to be 3x plus 8. Okay, now when we're multiplying here, there's nothing really to combine. We can make it 5x times x plus 4, but I'm just going to think about removing factors or simplifying factors, common factors out of both the numerator and the denominator. The x plus 4 on top cancels out with the x plus 4 on the bottom. So what are we left with? Well, this looks like on the top I've got 5x. On the bottom I've got 3x plus 8, but then I do have to remember my excluded values. I did get rid of an x plus 4 on both sides, which means I need to list negative 4. Whoops, let me get rid of that. X cannot be equal to negative 4, because negative 4 in my original expression would not have worked. However, negative 4 in my simplified expression does work. So you do need to list out the x cannot be equal to negative 4. What we also need to keep in mind is were there any values of x in the original expression that wouldn't also work? And if you look at this fraction right here, specifically 2 over x, we can't have 0 as an x value either, okay? So when we go back to write our answer, we cannot have 0 either. Let me make it better, 0 here. X cannot be -4, or it cannot be 0. And just to show you that, to be sure, what I did was I typed in the two functions. The blue one here is the original function, what we started with. The red one is our simplified answer. And you can see there are two values of x, -4 and 0, that do not work for the first one, but do work for the second one. So we do need to list both of those. We do need to list -4 and 0. All right, let's try another one here. X minus 6 minus x over 6 minus x over 3, all divided by x over 5 minus 7/10. Now, neither of these are simplified because there are two fractions in both the numerator and the denominator. So let's go ahead and try to simplify both. I'll do the numerator in red. I'll do the denominator in blue. We'll start with the numerator. So if we have x over 6 minus x over 3. Well, if I think about my denominators, if I count by 6s and count by 3s, there's no variables here, so we don't need to really work too hard. We need to multiply the second fraction by 2 over 2 to get this into sixths. Okay, so we're going to have x over 6 minus 2x over 6, because x times 2 gives me 2x, and 3 times 2 gives me 6. So then I've got my correct denominator, and then if I have 1x minus 2x, that gives me -1x, so -x over 6 for my numerator. This is the simplified numerator. Now for the denominator, it's going to be very similar. We're going to have x over, whoops, let me go back to blue here. Blue, so we got x over 5 minus 7/10. If I count by 5s and count by 10s, excuse me, the common denominator there is 10. Count by 5s, count by 10s. The first number they have in common is 10. So I need to multiply the first fraction by 2 over 2, because that will give me over 10 on the bottom. So that will be 2x. And then 7 over 10 is already in tenths, so I don't need to leave that. I don't need to multiply that by anything. So I've got 2x over 10 minus 7 over 10 leaves me with 2x minus 7 all over 10. This is my simplified denominator. So really what I've got is I've got the fraction I've got in red over the fraction I've got in blue, and it's basically one big ugly nasty fraction. And how do we simplify it? We simplify it by taking the numerator times the denominator of the reciprocal. Okay, so let's do that. We're going to have -x over 6 times the reciprocal, so we're going to have 10 over 2x minus 7. There really isn't a whole lot of simplification to do here. If we think about diagonally, x doesn't really have any common factors out of 2x minus 7. 6 and 10 can be simplified a little bit. We can simplify that down into 5 and 3 if we divide them both by 2, because that would be a common factor. But really, other than that, I don't see a whole lot here that we can simplify. Okay, so what we're going to do, we're going to just multiply straight across. -x times 5 is -5x. And 3 times 2x minus 7, that's distributive property, becomes 6x minus 21. And I would say this is your answer right here. We don't need any excluded values because if you look at our original denominator, that's just a 10 here. Okay? You know, there's nothing here that's going to make the original expression 0. There's no x value that could make the original expression undefined or 0 in the denominator because we don't have an x. So there's nothing really to worry about. This right here is our answer, -5x over 6x minus 21. Number 3 here, 2 over x minus 4, all over 2 over x plus 3. Now, like I said in the first video, 2 over x and 2 over x, while they are like terms, they're exactly the same, they do not cancel each other out because they are not common factors. So we can't just make this -4 over 3 and be on our merry way. It does not work that way, so we can't get rid of those 2 over x's just because they're common factors. So let me try to erase some of this blue writing here and kind of make do with what we got. All right, so we need to simplify both the numerator and the denominator. I'm going to do the numerator first. We're going to have 2 over x, that's a 2 over x minus 4. I'm going to make that 4 over 1. So now the common denominator here that we want to use is going to be x, okay? It's going to be x. So the first fraction, 2 over x, already has a denominator of x, so that's not going to change. It's still going to be 2 over x. What I need to multiply the second fraction by is x over x. Okay, because that will give me a common denominator of x. So that'll be 4x over x. Okay, so that's the numerator, and we'll see if we can't simplify this a little farther. 2 minus 4x. I don't know if there's much we can do here, so we'll just leave it as 2 minus 4x all over x. Okay, denominator. We've got 2 over x plus 3. Make that 3 over 1. It's going to be very similar to the numerator here. It's still going to be 2 over x plus something over x. And once again, we're going to need to multiply by x over x to get 3x over x, which leaves us with 2 plus 3x all over x. So when we go to simplify this, here's our new fraction. Put a fraction bar underneath it, underneath that numerator, and we can go ahead and go simplify. We can multiply by the reciprocal. So we'll have 2 minus 4x all over x times the reciprocal of what I've got in blue. So x goes on top, 2 plus 3x goes on the bottom. So there is something we can cancel here. The x on top and the x on bottom, they'll go away. I don't really see anything else here that can be simplified. So we're left with what looks like 2 minus 4x over 2 plus 3x. The question then becomes, are there any excluded values? And the answer is yes. We took an x out of the denominator of the original expression. Okay, so that is the value we need to list that would make it undefined, and that value, of course, is 0. So this right here is our final answer, 2 minus 4x over 2 plus 3x, as long as x is not 0. Let's try one more here. 3, oh, that's a 3, by the way. Let me rewrite that. This is a 3. 3 over x plus 5. All over 2 over x minus 3 plus 1 over x plus 5. All right, so the numerator, I would say, is simplified because it's a singular fraction. There's nothing here that we can factor out to make it smaller, but the denominator, we can. Now, if you think about x minus 3 and x plus 5, this is going to be very similar to the first example where there are no common factors here between x minus 3 and x plus 5. So really, to find what our numerator is going to be, we need to take this denominator times the opposite numerator, and then this denominator times the opposite numerator, and then for the common denominator, we multiply the denominators together. Okay, so what this is going to look like, and I'm doing the denominators in blue, so I'm going to stick with that. I'm going to take 2 times the opposite denominator, so x plus 5, plus, since we're adding the fractions, 1 times the opposite denominator, x minus 3, and the denominator of this fraction is going to be x minus 3 times x plus 5. Okay, so let's simplify the numerator of this fraction I've got in blue, so we'll have 2x plus 10, then times 1, so nothing's going to change, so it's going to be x minus 3. All of that is going to be over x minus 3 times x plus 5. Put the x minus 3 in parentheses, and then this simplifies down to 2x plus x is 3x, 10 minus 3 is 7, all over x minus 3 times x plus 5. Okay, so what we've got then for our new fraction is going to be, let me go back and get the numerator, is going to be 3 over x plus 5 over 3x plus 7 over x minus 3 times x plus 5. Okay, so when we simplify this, remember to undo this giant fraction, we need to multiply the numerator by the reciprocal of the denominator. So this becomes 3 over x plus 5 times, and now on the next fraction is going to be the reciprocal, so it's going to be x minus 3 times x plus 5 all over 3x plus 7. To simplify this, think about your common denominators. Whoops, let me go back, hit the wrong button there. What can we get rid of? Well, it looks like there's an x plus 5 on the denominator of the first fraction. There's an x plus 5 in the numerator of the second fraction. Those will cancel away. Other than that, I don't see a whole lot here that can be simplified out. So we're going to say that this is equal to, we'll have 3 times x minus 3. If you want to make that 3x minus 9, you certainly can. And then on the denominator, we're going to have 3x plus 7. Now the question becomes, were there any values of x that need to be listed as excluded values? And the answer is yes. We know that x cannot be negative 5. That's the same rules as section 3. If we take something out, we probably have to list it. So x cannot be negative 5. Whoops, let me go back to my pen. -5. But there's also one other value, this value right here. What makes x minus 3 equal to 0? Because that would throw the whole fraction off. And that value is positive 3. So x cannot be -5, or it cannot be positive 3 either. So this right here is our simplified answer for example number 4.